Well folks, I am at an absolutely pristine Sennen Cove today. I've come to the very far end of the beach, which is virtually deserted. The other end there must be about 3,000 people because we're in the middle of August. It's 25 degrees, wall-to-wall sunshine. It's magnificent. But as you're probably aware, this channel doesn't come just to show you beautiful beaches. We try and understand a little bit about what's going on. So we're going to turn inland and just have a look at the rocks that form this outcrop on the cliff here. These are not your typical Cornish rocks. They don't have that sort of 60-degree cleavage plane through them. They're not mudstones or sandstones. What we have here is granite. Granite of the Land's End Intrusion. And basically this granite pluton forms the Penwith Peninsula. So if you take a line from Hale down to Marazion, everything west of that is dominated by this granite. There are still sections of mudstone and sandstone, but they're only sort of little remnants around the edges. So this is a granite outcrop forming the cliff here at Sennen. And if I pan down slightly, you can see at the base of the cliff there, we've got something else going on. We've still got some big lumps of granite there, some big boulders of granite, but they're not in situ anymore. A lot of them are very well rounded, and they're held in a sort of sandy, gravelly matrix. I'll give you a little time to think about that while we actually have a look at the granite a bit close up, and have a look at the Land's End granite in particular. So I've picked this boulder here. So you can see the beach is covered with boulders, and a lot of them are the same, but I've picked this one here because it actually tells a bit of a story. So what we've got two dark veins running from top right to bottom left through the image there. They are tourmaline veins, and they've sort of been intruded after the granite. So granite is an igneous rock. It intrudes, it doesn't form. So it's an intrusion rather than a formation. Just a slight technical term there. But effectively, what this means is this started off as magma. Magma is exactly the same as lava, but it's not lava that's erupted from a volcano. It's magma is exactly the same molten rock, but that doesn't reach the surface. In the case of the Land's End intrusion, this would have intruded at several kilometres depth. If you imagine at the time this rock was intruded, Cornwall was underneath the Variscan mountain range, which was a mountain range taller than the Himalayas are today. And you can imagine that the pressure from all of that rock above it, several kilometres of rock, pushing down on every square inch of ground at the base of the continental crust, was putting immense pressure on the rocks that were already there. And it took several million years for that mountain range to form, but it was actually eroded very quickly, just a couple of million years for that mountain range to erode. And what happens when you put something under extreme pressure and then release that pressure, it goes up a state. So in this case it went from a solid to a liquid. It melted. You can do the experiment at home by shaking up a bottle of Coca-Cola and then opening it, and then all of the little carbon dioxide atoms in there, they go from being in a liquid state or a pressurized state to expanding and forming a gas, and the thing explodes everywhere. It's a very similar arrangement to what happened here, but in this case the rocks went from being solid to being liquid to being molten, and that was as the mountains eroded. So what you've got are three main constituents of granite. You've got these milky white crystals, which I'm sure you can see, quite large crystals in the Land's End intrusion. I'll show you a slightly closer one here, look. But we've also got, you might see, the rocks here are very weathered because we're down below the high tide mark. But what you've got a second main mineral, which is like a dark grey glassy mineral, normally a couple of millimetres across, and that is quartz. The white milky minerals are feldspar, a mixture of plagioclase and orthoclase feldspar. And the feldspar here can be either this milky white or it can be a pink colour, which is why some of these granite boulders look slightly pinky in colour. But the pinky crystals are far smaller than the big white ones, and therefore you can't see them individually unless you get a hand lens out on a very fresh piece of granite. And there's a third main mineral in there as well, called mica. The mica is it's a very platy mineral. You may remember muscovite mica from school, which is where you can sort of make very thin sheets, tear off very thin sheets of this crystal, normally a brownish crystal. But here it's fairly clear, and it gives you the little sparkle that you get sometimes when you're walking past the rocks on the beach. And if you have a look, these rocks extend all the way across the beach. And the milky white crystals, the feldspars here, you notice how they're all aligned. That would suggest either that there's been some kind of flow to this magma, or that they've settled. They would have formed as very large crystals. So for crystals to form this large, they would have formed over tens of thousands, possibly hundreds of thousands of years. They're very slow to cool, this magma under the ground. And then they may well have settled as the material, the magma was still semi-molten and able to still move. But either way, they are orientated all in the same direction, which is fantastic. And it gives you an indication of which way up the granite is. These are big boulders, and the ones that are orientated horizontally tend to be the right way up. Those like these that are orientated at 45 degrees means that this boulder has rolled somewhat and is not the right way up anymore. We were also talking earlier about what the sandy material was. So I'll just recap. We've got the granite up there, we've got the sandy material down there, and actually those big boulders over there are in situ as well. So we got granite, sand and boulders, followed by granite. And what that is, that's a remnant of climate change, guys, but not the sort of climate change we're seeing today. What you've got there is a raised beach. So at the time that beach formed, there was far less ice around than there is today, and sea levels were far higher. In this case, about 15 to 18 metres higher. And what you've got there is a cross-section through the beach that was there possibly 500,000 years ago, possibly 1 million years ago. I don't know the exact age of this cliff. What I'll do is I'll look it up and I'll see if I can put it in the captions for you. And then effectively what you've got there is mirrored down here today. You've got a selection, or it's predominantly a sand matrix, but you've also got these boulders and cobbles and other bits mixed in, and if you were to dig the ground here you'd find these big cobbles of granite, and it's exactly copying what you've got there. And we can tell that this isn't just one isolated thing, because if we pan around here, around the cliff, you can see that raised beach continues all the way round to the headland, and therefore, because it's all at the same level, that tells us that it's been formed by water. It's really interesting, guys, that is now the erosional face, and there's only these tiny remnants of this raised beach left, and you can see how close they are to the granite cliffs. And what that means is that in a few thousand years time there won't be any raised beach left here, and all of those clues that we've had, or that we've got now, as to the history of this environment will be gone. And you can see in the raised beach there that you've got predominantly sand, but it's layered. You've got the darker layer at the top of the topsoil, which is obviously more modern after the beach was formed and after after the sea levels lowered. And then underneath it you've got these big boulders that are randomly orientated, just how you'd expect on the beach. And what it does also mean is that around here you'll find that there are a lot of boulders, some of these down here as well, you'll notice, are very well rounded. And that's because they've not just been on the beach here, they've also been in the raised beach too. So they might have been in that beach sort of 100,000 years ago and have now fallen out and are on the beach again. And that's why you get some very well rounded boulders in the on the top of the beach here. So if you're still watching, thank you very much. I've been the Down to Earth Geologist. Don't forget to like and subscribe for more content like this.